Hi, welcome to the screencast session on week 6 max heap. So in the part 1 session, we have already implemented two functions. So let's do the part 2. The part 2 is exclude the delete max and inserting a new element. It's not a particular, hard-coded list of elements. Every time we try to delete the maximum element, every time we are trying to insert a new element into the heap. So this is the first function we are implementing. So we have that initialization, maybe item which you want to delete is we don't know, so that we want to make it's a none. So till now we don't know what you want to delete. So basically the delete, so as usual that always the deleting is the root element, but before deleting the root element we try to swap whenever that the heap is not empty, we try to swap that last element and first element. For this, if my self dot heap, as you know that heap is it's declared as a, which is a not empty one, we have some elements inside of your heap. So then we try to swap that first element and last element of the heap. So that's very simple, that self dot a is the 0th element, so it's what is available, and this one and the last element, the self dot a of this -1. So these two are swapped, so that the last element and first element is swapped. So the bigger element, it comes to the last index position. So the smaller element, it comes to that as a root element or smaller element or some element. We don't say that smaller element. So we are getting the last element to first and first element, but root element, it comes to the last element. So then we try to get that particular, the bigger element from the particular whatever the you have that heap. So for this we are using a pop, always that recent element is going to be popped. So once we got it, the popped element, we try to reheapify. So whatever that the heap is available, we try to do the heapify from the 0, because already we have that heapify method earlier, that's we have done. So this part is exclusively for removing the max element once we got the last element. So then we are trying to apply that heapify on the particular list after deletion. So this is so far, but whatever you got that particular deleted element, that should be returned because that's a max element. So that max element already we got it from the item, so that's going to be returned by the delete max. So and this is finally we try to return the particular deleted element, so whatever so far, and without losing the property of this max heap property. So let's build that fourth function or fourth method. This is inserting each element into the heap. So adding always that new element is at last of the list. Whatever the D, which is the data element which you received, I want to append it into that a dot append. So whatever that element you received, that is appended. So after appended, we try to get it. We try to heapify you need to apply, but the heapify we are applying means swapping whenever the property is not matched. So whenever new element is added, that's ended at the last. From the last to root element, we try to check it whether that heap property is protected or not. For this, the index of the last element we try to get it, that is self dot a, whatever the length is there, the last index position is not n, it's n minus 1. So then we try to swap it, the last element to root element, by protecting the property, so that while my index, so whatever so far index, if it is greater than 0, then we try to do that every time, protecting the property. And how to get that root of any element is, it's also standard calculation, that is simple index, so -1, so divide with 2. So if that second element root you want to find out that, so it's going to be that, so we try to do that third index position, because second element is 0 1 2, and then it is going to be that index -1. So that's index -1 is 2 minus 1. So what is the root of this one, we want to find out it is, you can do it with integer division of operation. So that 0 is having the left descendant is 1 and the right descendant is 2. The index position of the 2 is having a root element of 0. That's simple. So bottom to top. So this is a standard calculation. What way you're finding that left and right descendant in this way. So this is the left of the kth element and right of the kth element. Similarly, the root of any index position you can find out in this way. So now, so we try to check it, whether that current index whatever it is there, that is greater than this root or not. So when this particular index, if it is greater than the parent of the self dot A, so whatever the parent is there, so whenever the children is bigger than the parent, so then we try to swap them, that is index is swapped with self dot parent of this particular A parent. Yeah, so the same thing, it's going to be swapped with reverse order, where the parent it comes to the index position, index it comes to the parent position. So we got it swapped. So once it got it swapped, so we try to make that new index position as parent of it, because once it is swapped, the new parent is it becomes like index position. So this case happened if and only that 63 line number property is satisfied. Otherwise we don't need to swap it. Simply we can do that, just breaking of this loop, because whatever new element is added, it is protecting the property of max heap. Then you do not do this particular bottom up heapify. So for this, just a break of this particular loop. So I think so far we have done. So this is the heap they are creating. So basically instance of the heap is created. In the 70th line number, they try to call that all of them are in ascending order. So if it is ascending order, if element is available, definitely after heapify we get the root element is definitely a 6, because root is always bigger than that. And after that, this is simple kind of hard coded building of max heap. But this particular inserting each element and inserting each element is a simple each element you are inserting. Then we try to delete that each top element from the heap, and finally whatever updated heap is there for each insertion and each deletion, you can see that. So let's run this. Hopefully it works well. Yeah, got it. So you can see that the first insertion, the root is going to be the 6. So whenever that the next insertion 7 you have done it, though, so that 7 is considered as the last element first, then we try to use that heapify from the bottom up. Similar way 8 also, as and when it is inserted, so then immediately try to call that heapify property of that using a while loop here. So you try to protect this property, this while loop is continuously works, and until this property is protected, that is root is always bigger than that. Say 8th left is 7, so 8th right is 6. So 6th left is there, similar with 7th left is there, 7th left is 5, 7th right is the 2. So that always you can check it, 2 into k plus 1, 2 into k plus 2. So that's what the property. And then we deleted 8 so far, and we deleted 7, and finally available heap is this. So hope you got it. So thank you very much. Have a nice day.